Ooh, counting it. Nice. All right, so standing waves on strings from the basis of, or form the basis of producing music. Okay, not all music, because of course there's the woodwinds and the brass, but string music anyway. Um, the different standing waves, right, small, the different standing waves, and this seems arbitrary. This is such a tiny blank, corresponding to different multiples of lambda over 2. Look at that giant blank for lambda over 2. Are called, starts with an H, harmonics, yeah. Okay. Now, when we talk about these different harmonics, we can't help but go back to talking about nodes and antinodes. And a node, look at that, capitals as if I'm shouting it. A node is a stationary region in a standing wave where total destructive interference occurs, so that the resultant wave is at a rest position. And so here we go. Here's our nodes. And then we could say, here I'll whisper it, an antinode is a region in a standing wave between the nodes where destructive interference occurs, resulting in a maximum. Oh my gosh. Am I having like one of those? Yeah, it's constructive. Oh man. Thank goodness for catching my own typos. Constructive. Good thing I whispered it earlier. Constructive interference occurs, resulting in a maximum vibration of the medium. And so here's an antinode. Earlier we were talking about harmonics, and we're still on that topic. So we've got nodes for this other waveform here, and antinodes as well. And earlier we were able to name harmonics. Now this is a different loop diagram of two different harmonics. Which harmonics are we dealing with here? Second and third, yeah. So if I was going to talk about harmonic numbers, I'd be talking about the second harmonic and the third harmonic. Now the first harmonic, even though it didn't actually show up in this diagram series, here I could draw it really easily, is going to look something like this. Okay, and I've made all of those strings be about the same length as each other, 1, 2, 3, and this would be the first harmonic. And of course there's two nodes and one antinode in the middle for that one as well. And we're always thinking about these diagrams as actually just representational of animations. Okay, so these are representations of animations. This particular textbook that I stole this one from showed it at a whole bunch of different positions, but really most people just think about the extremes, right? So nodes are spaced an equal distance apart. And when I say that, take a look at the diagram. You guys can see the nodes are all equally spaced. And specifically, the distance that they are apart is half a wavelength. Lambda over 2 apart. The antinodes, on the other hand, are exactly at the middle point between each pair of nodes. And again, you can see that visually just by looking at the pictures, right? So standing waves are an even number of half wavelengths. Lambda over 2 that fit into a closed region. Now that's true for strings. We're going to find as we get into resonating air columns that that's not quite true. So we're going to fudge it a little bit. We'll figure out how it's slightly different when we talk about resonating wind instruments, okay? But for strings, integer numbers of half wavelengths. And we can see that visually just by looking at it, okay? Anyway, the natural frequency, there's one of those synonymous terms. The natural frequency, also called the, what was it again? Blank harmonic. First, yeah. The first harmonic. I'm going to throw in a word, produces the longest half wavelength. Take a look. I'll zoom up here. Look, you see that this half wavelength is bigger than the next half wavelength. This half wavelength is bigger than that half wavelength. There's not going to be another half wavelength that gets longer than the first one. The first one's as big as it gets. Now, if the wavelength is as big as it gets, doesn't that mean that the frequency is as low as it gets, right? So the fundamental frequency is the lowest frequency that thing will play. All the other frequencies are higher frequencies. So the second harmonic, the third harmonic, the fourth harmonic, these are all going to be higher frequencies and shorter wavelength as well, right? Anyway, these fundamental frequencies produce resonance. And we say an integer number of half wavelengths fits into the resonating region. I can't remember if it was a YouTube video that I saw or a TikTok thing in my news feed or whether it was a textbook. I really can't even remember where I saw it. But at some point in my personal history, somebody said, oh, when you have multiple harmonics playing at the same time, that's just like potato chips. And I was intrigued. I was like, tell me more. I do like potato chips. And they're like, oh, a Lay's potato chip is nice and smooth. And when you fry it, you know how it makes that sort of curvy shape to itself? That would be like a nice second harmonic. And if I have a higher harmonic, by the way, when you have higher harmonics playing simultaneously, we call those overtones. How many music people have heard the word overtones? No? Can you? So I got a few nods of the head. And overtones when you have those higher harmonics played on top of the fundamental. Okay, so we play these things at the same time. If I have this frequency and then the next overtone up playing simultaneously, it would be like adding a Lay's potato chip and the crinkle cut of a Ruffles potato chip and making them happen at the same time. And of course, when you have a Ruffles potato chip, like I even put in some branding there, the Ruffles potato chip gets that S curve because of the frying action, but it also has the original crinkle cut. So we have this superposition of two different waveforms. I just thought that was a delicious way of thinking about it. I personally like the Ruffles, mostly because it seems to have more surface area and they can jam pack in more salty flavor. But still, the other thing is when I have overtones played on top of each other, it's true of Ruffles, they've got more salty flavor. But what people say is that when you have overtones played on top of each other, they call it a tonal quality. So the tonal quality is richer. You hear those words? A richer tonal quality when you have superimposed overtones playing simultaneously. And that's something that definitely happens when you have a high quality instrument like a Stradivarius violin. You'll get the primary tone, and then you'll get overtones, and together those things come out all at once when you play the instrument, and it causes a rich tonal quality. Okay? I'm not even musical, and I kind of know these things, but I do like potato chips. I know that. All right, so sound interference. Again, just to recap this, when we have crests overlapping with each other, we get, starts with a C, constructive interference. And we have overlapping crests and troughs, we get destructive. And I'm so glad that nobody said deconstructive, because deconstructive is not what we call this. So I'm going to write the word deconstructive, and then I'm going to put an X through it. Yep. No, it's destructive that we're talking about. And then I'm going to put a stick of dynamite next to it, and then I'm going to light the dynamite on fire, and then I'm going to toss it into that circle where deconstructive is, and I want to just like blow it up so that we never say it again. I've obliterated the word deconstructive, okay? Deconstructive is a word, don't get me wrong, but when you're doing something in a deconstructive way, you're carefully dismantling it. That's what deconstructive activity is, careful dismantling of something. Destructive is destroying it, just destroying it, not careful dismantling, okay? So this is destructive interference, not deconstructive interference. Now, if you're looking for like a quick summary of what was going on with the harmonic numbers, again, in the bottom here, in the bottom right, there's a quick little success toolkit. I've got some harmonics drawn up to the fourth harmonic, and we could talk about that Fn equals NF1 as sort of an outgrowth of that idea.